So let's start by taking up A here. Now I got to point out something right off the bat that I've used H plus here instead of H3O, but they mean the same thing. So what we need to do is some matching up. So whenever we're talking about H plus, that's going to correspond with our pH answer. So there'll be no subtraction. However, pH and the H plus and POH don't go together. That means some subtraction is going to be necessary, and that's also going to apply when we get down to question B, where OH is going to go with POH. And then with the other value here, we're going to have to do some subtracting. So it's always about matching up. H plus or H3O goes with pH, etc., etc. So in the very first one here, we're given a concentration, that's in moles per liter, and since it's H plus, we can immediately go ahead and find our pH value. So this one's just a little complicated to type into the calculator, so let's cut over to see how that's done. So with this question here, there's quite a few things that we're going to be typing in. So the first thing we'll do is we'll type the minus log part. And then, just like as if we were going to type an Avogadro's number, let's type 1.0 exp. And now I need a negative exponent, so it's going to be to the negative 5. And we hit equals, and there is our answer. So let's go back and stick that in. So you can see that your answer is 5. Now, our next step is we're going to have to figure out the pOH, and I can just do it down here. It should be simple enough that if we know the pH is 5, it's just going to be 14 minus 5, and that will give us our answer of 9. There we go. Now at this point, we can also do classify it as an acid or a base, and really we just need to look at the pH column. If it has a pH of less than 5, it's got to be acidic. So looking at the next one here, B, our answer we're going to do is, we have our concentration. So for B, we're just going to do the negative log of the value, 3.0 times 10 to the minus 8. And where is it going to go, this answer? It is going to go over in the pOH column right here. So when you type that value in on your calculator, you get 7.52. To go back to this column now, we're just going to take 14 and subtract 7.52, and you get your answer of 6.4. Now, based on that, now we can go ahead and say, is this acidic or basic? Obviously, it is acidic, and there you go. So just the rest of the examples are going to follow the same line. Just know when you're doing an answer, you just need to look at this to tell you what column it's going to go on into, and then you're going to subtract. So here are the rest of the answers. Again, you can see all of our acidic or basic is all based on the pH column, and that's how I came up with all these. And this one's a 10 molar. We get a negative value, so it is possible to get answers off the pH and pOH scale here. So all of these questions here are using the negative log equation to solve. Now question 2, we're going to be using the other equation, the 10 to the power of pH or pOH. Again, it all depends on what I give you. Now, probably the easiest part of this question is simply to classify things as acidic or basic right off the bat based on the pH values I'm giving you. If pH is 3, it's got to be acidic. If a pOH is 2.6, remember it's backwards, it is going to be a base. And pOH of this value, again, also a base. Just think about those in terms of the pH and pOH. So on to the calculations here. Again, we're going to match up pH and H plus and pOH and OH minus. There is sort of a classic mistake that people make on these questions. So first one here, A, all we're doing is we are going 10 to the power of negative 3, right? There's our 3. And all that is going to yield for us is simply the answer of 1.0 times 10 to the negative 3. Now here's where people go wrong. What they want to do over in this column here now is they want to subtract, right? They want to subtract from the answer we just came up with. They want to say 14 minus 1.0 times 10 to the minus 3. Again, that number is very small. It's 0.001. Inevitably, the only answer you can ever get, if it's always 0.01 or less, is 13.99. That is incorrect. If a pH of 3, what we need to do is we need to subtract right off the bat. So your subtraction ends up being the first thing you do. So you're going to say, okay, what's 14 minus the value I'm given at the start of the question? That's 11. Well, 11 now ends up being the value that you're going to raise to the 10 to the minus 11. That is going to give you the answer which just happens to be 1.0 times 10 to the minus 11. And the only reason that's working out is because these are whole numbers here, 11 and 3. So the subtraction doesn't come at the end of the question like number 1. It actually comes at the beginning of the question. So when we get on to B here, our answer is going to appear in this column. So if you just want to go, B is 10 to the minus 2.6. Raise that up. You should get that answer. Again, I've given the moles per liter at the top of these columns. Remember, these are all molarities. You're calculating a concentration right now. And if we want to get this column right here, our move is going to be, we're going to take 14 and we're going to subtract 2.6. Again, that's the 2.6 here. And what's that? 11.4. So 10 to the minus 11.4 is how we are going to get this answer right here. And it works out to 4.0 times 10 to the minus 12. There's the other two answers similar to that. Question 3 through 7 or whatever this goes to, you're going to be using a couple of different formulas. You're going to be using your C equals N over V formula and your dilution formula. And then you're going to be using the pH formula to go with it. It's a combination of stuff we learned in sections 3, 4, and 7. So get those done. You'll have to check the paper for the full solutions that I will be posting.